Good day to each and everyone. I am Genelle Tejano from grade 12 STEM Boyle, and I will be your reporter number 1 in General Physics 1. In this report, we will illustrate the concept of a moment of the inertia and walk through calculations for both single object and multiple object systems. Moment of inertia is an important topic and appears in most of the physics problems involving mass in rotational motion. Usually, moment of inertia is used to calculate angular momentum. We will learn more about this topic in the following paragraphs. So what is the moment of inertia? The moment of inertia is defined as the quantity expressed by the body resisting angular acceleration, which is the sum of the product of the mass of every particle with its square of the distance from the axis of rotation. Or, in more simpler terms, it can be described as a quantity that decides the amount of torque needed for a specific angular acceleration in a rotational axis. The moment of inertia is also known as the angular mass or rotational inertia. The SI unit of moment of inertia is kilograms times meter squared or kg times m squared. So the greater the moment of inertia, the harder it is to rotate the object. Moment of inertia of a body depends on the position and orientation of the axis of rotation. It also depends on shape, size of the body, and also on the distribution of mass of the body about the given axis. For example, if you try to rotate a long rod about its center, just assume it's a long rod. It's easier than rotating the same rod about one of its ends. This is because the mass in relation to the axis of rotation is more concentrated closer to the center. Next, moment of inertia formula. In general form, moment of inertia is expressed as I equals to mass mr squared, where m sum of the product of the mass and r is the distance from the axis of the rotation. So, let's go to the moment of inertia for single objects. In simpler terms, the moment of inertia is a measure of how difficult it is to rotate an object around a certain axis. Different shapes have different formulas to calculate their moment of inertia. For example, for a solid disk, we will use the formula I equals to 1/2 mr squared about its central axis, where m is the mass and r is the radius of the disk. For a thin rod, the formula is I equals 1/12 ml squared at the center and I equals 1/3 ml squared if it rotates at the end, where L is the length of the rod and m is its mass. And for a solid sphere, the formula is I equals 2/5 meter square mr squared about its diameter and I equals 2/3 mr squared thin spherical sphere, where r is the radius and m is the mass of the sphere. So example calculating the moment of inertia for a rod. A thin rod has a mass of 1.2 kilograms and a length of 0.40 meters. What is the moment of inertia of the rod if it rotates about its center of mass? Step 1. Determine the mass and the length of the rod. The mass and length of the rod have been given in the problem, where mass equals to 1.2 kilograms and length equals to 0.40 meters. Step 2. Determine whether the rod will rotate about its center or about one of its ends. As stated in the problem, the rod will rotate about its center. Step 3. Use either the equation 1 equals to 1/12 ml squared or 1 equals to 1/3 ml squared to calculate the moment of inertia for the rod rotating, respectively, about its center or end. Because the rod rotates about the center, we must use the first of these two equations to calculate the moment of inertia of the rod. So, substitute I equals 1/12 times 1.2 kilograms times 0.40 meters squared. So, calculate. The answer is 0.016 kilograms meter squared. The rod has a moment of inertia of 0.016 kg meter squared. Moment of inertia for multiple object systems. How to calculate moment of inertia for multiple objects around an axis? Step 1. For each object, identify its mass and distance to the axis of rotation. Step 2. Use the formula I equals summation mr squared to calculate the moment of inertia. Examples. Three objects are rotating around a mutual axis of rotation at a distance of 3 meters. The objects have masses of 1 kg, 2 kg, and 3 kg respectively. Calculate the moment of inertia of the objects about the axis of rotation. Step 1. For each object, identify its mass and distance to the axis of rotation. Where object 1, where m equals 1 kg, r equals 3 meters, object 2, where m equals 2 kg and r equals 3 meters, and object 3, where m is equal 3 kilograms and r equals 3 meters. Step 2. Use the formula I equals mr squared to calculate the moment of inertia. So, substitute and calculate. The answer is 54. The moment of inertia of the spheres about the axis of rotation is 54 kg or kilograms times meter squared.